So these are the chapter objectives, because we will try to cover these things in this chapter. Dear students, first of all, we will try to understand what are routed protocols. Then we will talk about routing protocols. After understanding the routing protocols, we will have some fundamentals discussion about the router or routing protocol operations, okay? Like how the router will do their operation by using the routing protocols. Then we will come and we will try to understand the classification of dynamic routing protocols, because you know that the routing protocols have two types, static, and there are two types of routing, okay? Static routing and dynamic routing, where dynamic routing use routing protocols, okay? The dynamic routing is totally based on what? Dynamic routing protocols. In the classification of dynamic routing protocol, we will try to cover the interior gateway routing protocol and the exterior gateway routing protocol, okay? And other things. And then we will specifically focus on the link state distant vector protocol and the link state routing protocols, okay? These things will be covered. These are some of the operations, okay? Cool start, network discovery, exchanging routing information, achieving convergence. These are some of the operations which we will try to cover in the part number 4 of this chapter. So these topics are very much common, dear students, and very much important, okay? Remember, these are basics, okay? And one thing more, that whenever you will attend any interview for the IT officer or network technician or administrator, okay, or network engineer, you will face these questions. The questions which will come from this chapter, okay? The interviewer will always ask about questions from this chapter. Like they will ask for the routing protocol, they will ask for the classification of routing protocol, they will ask for the distant vector routing protocol, the link state routing protocols, okay, the classful and the classless routing protocols, so on. That's why this is very much important, okay? I'm sure you guys will have a constant focus during this today lecture. Okay, any question here about the chapter contents?
Not yet, sir.
Okay, good. Let's continue. So as I told you before, that this chapter consists of five parts. Part number 1 up to part number 5, okay? We are going to start from the first part, routed protocols. So let's try to understand what is routed protocols. 5.1 routed protocols. Dear students, you know this, that what is protocol? You know the definition of protocol, okay? And you also know that we are talking about network protocols, and we are the routed and routing, both are the network protocols, okay? Dear students, a routed protocol is a protocol by which data can be routed. By which data can be routed. Routed means by which the data can be carried from one point to another point. And this is also known as a what? Data carrier protocol, because these protocols are responsible to carry the small pieces of data over packet network. Okay, over the packet network or over the Ethernet network. These protocols are responsible. So the router, there are very common types of routing protocols. The most common one is IP, which is widely used almost everywhere. The IP is in use, okay? So IP or Internet Protocol is a data carrier protocol or routed protocol. Apple Talk is a routed protocol. IPX is a routed protocol, okay? But the good thing that Apple Talk was just only developed for the Macintosh computers by the Apple Corporation, So it's also phase out. So this was developed by the Cisco. The IPPX was developed for the Cisco for the packet exchange purpose, but it's also parked. It's totally parked by the Cisco. Okay. So the only protocol which is still in use is IP, Internet Protocol. Okay. So it means that we have only one protocol which is responsible to carry the data in the network is IP protocol. Dear students, remember in the routed protocols, we must have an addressing scheme. Okay, the addressing scheme is required here. Why the addressing scheme is required? Because you know that the routed protocol is responsible to carry data. Carry data between what? Between 2 points. Like let's suppose, for example, this is point A and this is point B. Point A want to send data to this. So definitely they will use the network, okay? And over this network, who will carry the traffic? The IP will carry the traffic. So the IP need to identify the A and B. That's why we need word addressing, because the protocol must identify the source or the destination. Subnetting is also required, okay? In the classless approach, not in the classful approach. Okay, so this was about what? Routed protocol. It's very simple, dear students. Okay, you already know about this thing, the IP. You already know. Just right now, remember that it's a routed protocol because it's carry data from one point to another point. And remember, the point will be not always the computers. Okay, there can be two routers. Okay, there can be two routers. Here, the IP is also carrying the data. Now, let's talk about the routing protocol. Routing protocols are different from the routed protocols. They are not data carriers, okay? They are the protocols which are responsible for some other operations like network discovery, like MAC table creation or MAC table population, okay? And the topology building in the router. So for such feature, for such operations, the routing protocols are responsible. So focus on the definition of routing protocol. A routing protocol is a set of rules. You know, the protocol is a set of rules, but this set of rules is used by who? By routers. For which purpose? To determine the most appropriate means the most optimum path into which they should forward packets toward their intended destination. As I told you before, the routing protocol will help the routers to choose the most appropriate or optimum path. For which purpose? For the data forwarding purpose. But remember, they will only choose when multiple paths will be available, okay? Then the routing protocols will help the router to do some calculation for the best and optimum path selection. Not just these protocols will help the routers to select the appropriate path. Dear students, routing protocol also help the routers to build and maintain routing tables. To build and maintain what? Routing tables. You know what is routing table? Because when the router, let's suppose in this topology, I have 3 routers. And I have 2 networks. For example, this is one network, is another network, okay? This interface here, their on IP address, this interface here, their on IP address. Every single interface of the router will have an IP address. And the router will hold a table. A table is called what? Routing table. For the purpose of what? For the purpose of to store IP addresses. To store what? IP addresses. IP addresses of who? IP addresses of their neighbors. IP addresses of the other routers which are connected to their neighbor. Okay, because the router is responsible to find the best path, and the router is also responsible to store all the information of the other routers. For this purpose, the IP addresses must be learned and must be stored. Where? In the routing table. Okay, so that's why we can say the routing protocol will make possible what? Building and maintaining of routing table. Okay, remember, routing table is not a database. Okay, it's a hierarchy. The third, routing protocols facilitate routers in network topology understanding. Network topology understanding mean what? Let's assume that this router 1. Who will help this router 1 to understand that how many routers are connected? If multiple paths are available. Definitely, the routing protocols will help him, okay? And who will help this router to know when any of the router goes down or any of the router is replaced or any of the router change their IP addresses? The routing protocols will facilitate this R1 to understand these topologies changes, okay? So dear students, we understand here that routing protocols are the set of rules which is used by the routers to determine the best path, to build the routing table and to maintain the routing table, and also to understand the topology. Okay. So this was about what? Routing protocols. Okay, any question here?
No, sir.
No question, sir.
Good. Let's try to cover more topics. Okay. Routing protocols, operating fundamentals. Okay, in order to understand the operation fundamentals, we need to understand these topics, okay? We need to understand what is the cold start of the router, what is the initial discovery of the directly connected interfaces, what is the network discovery, what is the exchanging the routing information process, what is the split horizon process, and what is the convergence, and then how to achieve convergence, okay? Remember, all these things are belongs to router and routing process. Okay, before going to explain these things one by one, we should understand the topology. We will try to understand all these things by help of this topology. Okay, you can see, dear students, I have 3 routers, router 1, router 2, and router 3. Okay? And here at this side, I have a network 10.1.0.0, and at this side, I have a network 10.4.0.0. And at the middle, this interface and this interface use this network, okay? 10.2.0.0. And here, these 2 interfaces are using this network, okay? So we are going to understand the operations of these 3 routers from the very beginning. Like, for example, let's assume that Shayak is power on the R1. What will happen after powering on R1? Okay. So now we will go back to the theoretical slides. Okay. Okay, Zainullah Abidin is complaining that he don't have my voice properly. What about other students?
We have your voice, sir, but sometimes it's
We
silent.
do have your voice, sir.
We don't have.
Okay, so you guys,
Could be due to his connection, sir.
uh, so everyone have my voice clearly, yeah?
You're fine, sir. I
Okay,
can
good.
hear you.
Okay, good. Zen, so it's the problem is at your side, yeah. Let's move on, dear students. Be patient, okay? So as I told you before that we are going to talk about these things, okay? These are the basic operations. Okay, but before, let's have a general overview of the routing protocols. As I told you before that the routing protocols will help the routers in these three areas, okay? So that's why here again I mentioned that all the routing protocols are basically perform the same task. The same task like building, maintaining the routing table, understanding the topology, okay, and also choosing the best path. All the all the routing protocols are responsible for this same basic job. And how they will do this? They will exchange routing updates with each other. Okay, they will try to learn the topology changes and to build the routing tables. Okay, and they will use the router to make packet forwarding decision. And also, all routing protocols are designed to learn about remote networks. Remote networks, in our previous example, the 10.1.0.0 was a remote network, and also at the other side, 10.4.0.0 was the remote network. Okay, every router is intended to learn those network route. So in this section, we are going to understand how the routing protocol will operate for these jobs. Okay, for these two jobs. In general, the operations of a dynamic routing protocols can be described as the following. The first step will be in the operation of the routing protocols. The router sends and receives routing messages on its interfaces. Dear students, let's assume that I have two routers. For example, this router and this router. This router have an interface. Okay, and why this interface, they will be connected to each other, twisted pair cable. Okay, whenever this router want to send some routing information to this R2, they will do this via this interface. Okay, via this interface, and this router will receive this information via this interface from this R1. And whenever R2 want to send information to R1, so R2 will send their information via their interface. Okay, so this is the very basic job of the router. The router send and receive routing messages on its interfaces. Second, router shares routing messages and routing information with other routers that are using the same routing protocol to learn about the remote networks. For example, if I have here another router, okay, let's suppose R3. R3 is connected with R1. So R1 know about R3, that R3 is connected with which network. Let's suppose there is a network 10.1.1.1, okay? But R2 don't know about this network. So who will inform the R2 about this network? Definitely, the R3 will share information with the R1, and the R1 will share the information with the R2 about this network, okay? About this remote network. This is the basic job of the routers. That they will always share the routing information with each other. But remember, dear student, it's very much necessary that these three routers must be in the same autonomous, okay? It means that they must use the same routing protocol. Like for example, there are multiple routing protocols about which we will have discussion. But right now you have to remember that all those routers will able to exchange information with each other when they will be operating on the same routing protocol. The third one, when a router detects a topology change, the routing protocols can advertise this change to other route. Let's assume, for example, this interface had IP, this IP address or IP from this network. Suddenly the network administrator changed the IP address. So it means here some changes are occurring. Or maybe one interface are added here, new interface is added here. So topology changes are made here, okay? So who will inform their neighbor routers about this topology change? So R3 will inform, okay? So R3 will detect the topology change and they will advertise those topology change to their neighbor routers or their network connected routers. Okay guys, so this was the story of the routing operation, but in a very summarized form, okay? A very summarized form. Okay, so let's assume Shaik is thinking that, okay, is the router will do it from the very beginning? No, dear, it is not the story. As I told you before that, let's suppose Shaik is going on and he is power on this router 1. This router 1, okay? So this router 1 or 2 or any router, when we power on, what will happen? When we will power on them, the case will be not like this, okay? Cool start. When a router power up, it knows nothing about the network topology because it's freshly powered on. There is nothing in their RAM and their running configuration file. So that's why they know nothing about anything. Even they don't know what is my IP address. Okay? It does not even know that there are devices on other ends of its links or not. For example, there are 3 routers. Okay, R1, R2, and R3. R2 is power on. See, R2 is connected with the R1 and with the R3. We power on this R2. It's cool start. Right now, after finishing their booting process, the router don't know who is router 3 and who is router 1 because they have not discovered their IP address. That's why they don't know about them, okay? The only information that a router has is a form, its own saved configuration file. Remember, dear students, the router have NVRM, non-volatile random access memory. Okay, so here we will have what? Configuration file. Just only the router will know about what is inside this configuration file and how to operate based on this configuration file. The router is just know about this. The router don't know anything about their directly connected devices. Okay, guys. So then what will happen after cool start? Remember, if these IP addresses, this interface IP is configured properly, if there is no issue in the IP configuration, then what will start? The router will start initially discovers its own directly connected network okay, directly connected networks. The router will start discovery of their directly connected networks. The router will start communication with this interface, okay, with this interface and with this interface to know about them. So this was the first step, cool start. Let's move on and try to understand what will happen after the cool start. Okay. We understand that during the cool start, the router had no idea about anything. Then what happened if the IP was properly configured in their interfaces, the router start what? Initial discovery of the direct connected interfaces, like they are directly connected interfaces. Okay. So let's see what happened after this process. Dear students, after this process, the router build MAC table and the IP routing table an IP table. Inside that IP table, the routers store the IP addresses of their connected interfaces, directly connected interfaces. And let me explain this. Focus on the R2. As you know, the R2 is connected on two interfaces, on this interface, this interface. These are the interfaces ID, okay, serial interfaces, S0/0/0 and S0/0/1. This is the MAC table of, the IP table of the routing table. They know right now that 10.0.0.0 is connected with this interface. You can see here. It's connected with which interface? With this interface. The router discovered that 10.3.0.0 is connected with this interface. You can see here. So see, router learned this. Why which process? Why the initial discovery of direct connected interfaces. And what about R1? The R1 learned that in this interface with the fast Ethernet 0/0 interface, which network is connected? 10.1.0.0. Okay, you can see here. This is the interface name, and this is the IP address, which is discovered by the router. What about this interface? S serial interface, okay? S0/0/0. This network is connected. 10.2.0.0. And the same story is here with the R3. Okay, guys, so this is the result of the second process, initial discovery of the connected, of the directly connected interfaces. Okay, guys, still now, the router, this R3, don't know about this network, okay? And the R1 don't know about this network, and even this network, okay? They only know about the direct interfaces. The R3 don't know about even this, okay? So the routers just know about their directly connected interfaces. Now, how they will know about other routers? For this purpose, there will be another process, okay? Let's move to that process. Any question here? It's very simple, okay?
No question, sir.
Okay, good. So after initial discovery, network discovery will take place, okay? And the network discovery, the routers will exchange the routing table with each other. So dear students, let me explain this. For example, before this was the routing table with each router, okay? The 10.3.0.0 belongs to which? Was the entry of which router? Was the entry of R2. You can see here. This entry was here. And the R2 shared this entry with who? With the R1. And now the R1 have the idea about this network. Okay? Let's focus on the R3. R3 got a new entry, 10.2.0.0. Who tell them about this network? R2 tell them about this network. Because R2 had idea about this network. You can see here, the R2 exchanged their information with the R3. Now the R3 know where is 10.2.0.0. Okay, guys? And you know, before the R2 had no information about this network, 10.1.0.0. And also R2 had no idea about the 10.4.0.0. But now you can see these two entries. Let me change the color to blue. Now you can see here the 10.1.0.0. Who tell them about this network? R1. Okay, so R1 share the information with the R2, and you can see here 10.4.0.0. Okay, this information is shared with R2 by the R3. Okay, and now R2 have the idea of this network. Is it clear, guys? So this is network discovery, because the router must collect these information, and they must store these information in their IP table. Okay. So how they did? First, they did initial discovery, then they did network discovery. In the network discovery, they found the whole network routers interface IP addresses. Very good. Let's move on. Okay, so here are the process. Okay, how the R1, R2, R3 exchange these information. So exchanging the routing information. Now the complete routing table will be exchanged with each other. Now you can see at the result of this process, these routers have what? The same information in their routing table. The same information. Like for example, router 1 no. Where is 10.1.0.0? Where is 10.2.0? Where is 10.3.0.0? Where is 10.4.0.0? Okay, the router 1 know about this. How they got the idea? Because the routers exchange their complete routing information with each other. Okay, so you know about this. This is the IP addresses of the networks or the interfaces. This is the interface name. And what about this hope? Hope mean, let's focus on this 10.4.0.0. This is the IP of this network, okay? The router 1 know that the 10.4.0.0 is available on which interface? On serial S0/0/0 on this interface, you can see. Okay, after how many routers this destination network is available? After 2 routers. One router is here, one router is here, so 1 and 2. And finally, this destination network. So the hop count represent what? The hop count represent the intermediate routers. The intermediate routers between the destination network and between the exact this router one. Okay, it's called hop count. So guys, after this process, every single router have a complete information about the topology, about all the connected routers. Maybe you guys are thinking that why the router is doing this, why the router is learning all the addresses of their network available routers. Dear students, if the router don't do this, then how the router will understand topology? And second, if the router don't do this, then how the router will select the best path? Okay? You can say that this routing table will be a data set for the router. Whenever they want to do calculation to find the best path, they will do analysis based on this available information. And based on this information, the optimum path will be selected. Okay, guys, so now let's understand split horizon. Okay, till now, if you guys have any question, you can ask.
Sir, if we add another router in here, I mean router number 4, it starts from cold or no? We need to process all these decisions.
If you add a new router there, so they will repeat the same processes, okay, from the beginning.
Okay, sir.
Like for example, you are going to add router 4, router 5, so definitely after adding, you have to power on your new connected routers. So when you will connect them, definitely they will repeat the same process, okay? They will do the cold start, they will do the initial discovery, they will then they will do the network discovery, then they will do what? Routing information exchange, okay? Okay, guys, but there is a problem. Okay. The problem, we have to avoid the same information sharing again and again. Okay? We have to avoid the process of sharing the same routing information again and again. How? Let's try to understand. And remember, when the same information will be shared again and again, so they will create a loop, a routing loop, okay? In order to prevent the routing loop, there is a process by the name of split horizon, okay? There's a process which is used to prevent routing loop, okay? So split horizon is a routing loop prevention technique. Split horizon prevents information from being sent out the same interface from which it was received. What does it mean? Explain. Let's focus, dear students. Okay, focus here. There are two routers. The split horizon is an important process. Try to understand, okay? And there's a second route. There is a network 10.1.1.1, okay? And there's another network 10.2.1.1, okay? And here is a network 10.0.0.0. Okay, so you know R1 know about this network and this network, okay? The router 1 know about the 10.1.1.1 and also it's know about 10.0.0.0, okay? But you know the router 1 don't know about this 2.1.1. Who will inform them? R1 will inform them, okay? So R1 will tell the R2 will tell the R1 that there is also a network by 10.0.1.1, okay? And the same information will be also here. Now, R1 have 3 entries in their routing table. One is about 10.2.1.1. And remember, dear students, the R1 receive this information on which interface? On this interface. Let's suppose this is serial 0/0/0 interface, okay? R1 learn this information via this interface. If there is no split horizon, then the R1 will again share this information with the R2 that I have 10.2.1.1 entry in my routing table, so you should also learn this. Where the R2 already know about the 10.2.1.1 because the R2 share this information with the R1. So see, if without split horizon, the R1 will share the 10.2.1.1 information with the R2. R2 will again share this information. Okay, so continuously a loop will occur. So in order to avoid this, that whenever information will be received on one interface, they should not send back on that interface. Okay, so for this purpose, we will use what? A process which is called split horizon. And remember, all the routing protocols is compatible with this process. All the routing protocols will do split horizon to avoid this problem, okay? Is it clear? Okay, good. So in our example, you can see our example, this example of slides. For example, R2 does not send an update containing the network 10.1.0.0 out of serial this interface because R2 learn about 10.1.0.0 through serial 0.0.0. So it means if a router learn the information on a particular interface, they will not share back those information on that interface. Is it clear? Okay.
Yes, sir.
Okay, guys. So after this process, okay, after exchanging the routing information, so see, the routers learn. Every single router have a complete information about the entire network. In this entire network, how many routers are here? 3 routers are here, okay? And how many networks are here? 4 networks are here. Network 1, network 2, network 3, and network 4. So right now, all the routers know about these 4 networks. What will happen now? Convergence will take place. What will take place? Conversion will take place. What's convergence? So see, the network has converged when all routers have complete and accurate information about the entire network. When all the routers got the idea about each other while sharing the routing information, then we will say that the network is now converged because the routers know about each other. Maybe some students are thinking, what is convergence? See, convergence is a time. That in how much time or how fast the routers will exchange or the routing information, or the routers will learn the routing information from each other. Okay, so that time is called what? Convergence time. Okay, and remember, the convergence is a collaborative and can be also independent. It's what? It's collaborative and it's independent. Collaborative mean what? Collaborative mean when all the routers will share information with each other. Independent mean when one router will share information with each other, okay? And also independent mean that when a router will independently calculate the available routing information to choose the best path. Okay, guys? So we understand that the convergence mean what? Collecting and completing the learning of accurate routing information and then deciding the best path. It can be done collaboratively and independently. Collaboratively mean all the routers will share information with each other. Independently mean that those information will be independently calculated by each routers to choose the best path.
Sir, could you clarify collaborative and independent by diagram?
Okay, collaborative mean baham yakjai equal convergence process by baham shawa wa ham infiradi mesh. Like before, there were 3 routers. How these routers learn each other? Because every router share information with each other. Let's suppose if router 1 was willing to share information, but router 2 was not willing to share information, then conversion was possible? Not. Conversion then was not possible because one router is not sharing information. It means they are not collaboratively sharing information, okay? Okay, after sharing those information, then independently mean each router will use those information to choose the best path. Because choosing the best path, calculating the available information is the router responsibility, where the router is individually responsible to do this, okay?
Okay, sir, thank you. Now it's clear.
Okay, guys. Achieving convergence. Remember, convergence means you and the guys understand. So here we have 3 routers. And how many networks? We have 6 networks. So you understand that the convergence means all these routers should collaboratively share the routing information with each other. So they will learn this information, and then what will happen? Each router will calculate those information. Like for example, when R1 want to reach this network, so there are how many paths? 2 paths. This is the first path. This is the second path. Which path is the best path? The router wants to calculate. So This is called what? That they will independently calculate it to achieve convergence. Okay, guys. So, as I tell you before, that convergence will take some time because sharing these information, learning these information, storing these information, and also calculating those information takes some time. How much time? It depends. Older protocols like RIP version 1, RIP protocol and IGRP protocol, okay, they have slow convergence. Modern protocol like OSPF, like ISIS, they have what? Short convergence. Okay, that's why we will call them. And older protocols are slow because they have larger converge time, and modern protocols are faster because they are what? They have short convergence time. Short convergence time means that they will take less time to share these information, to learn these information, and also to calculate those information for the best path selection. Okay. So when they will take less time, we will call them what? Faster.